Hey programmers, welcome back to day 6 of the Advent of Code. So let's hop into today's problem. As always, we have a walkthrough coming up, so spoilers ahead. In the day 6 problem, there's a little bit of a narrative behind the input. They tell us that there's basically different groups and they all have to answer questions and all that jazz. I'm just going to remove and ignore all those story elements and just talk about this problem in terms of its input at face value. So here I have the example contents that you might have in your input file. So what you'll notice is most of the contents are going to be alphabetic characters, and it looks like between different groups of characters we have a new line separating them. And so technically wherever we have a blank line, that separates one group of people, we'll say, from the next. In other words, I have a few different groups here. I have group 1, 2, 3, 4, and 5. Again, in the context of our code, we just need to separate our different groups by a blank line. But what this problem has us do is interpret each group as well as each line in that group as a person. In other words, if I look at my very first group, there's only one person in that group because there's only one line in that group, right? And so what I have to do is basically determine what are the different characters that any person has within a group. In other words, if I had to look at every line, what are the characters that that line has as contents? And so if I analyze a single line in group 1, I have the characters ABC, so that tells me that, hey, in group 1, those people span the characters ABC. Group 1 is kind of boring because it only contains a single line or a single person in the context of the problem. Let's move to group 2. What you notice in group 2 is it has 3 separate lines, and that represents, 3 different people. And although there are 3 different lines, technically this group would still span the same number of characters, right? In other words, the first line of group 2 covers an A, the second line of group 2 covers a B, and the third line of group 2 covers a C. So that means in total, group 2 spans the characters A, B, and C. Things get really interesting on the third group. If I look at the third group, just from the first line, I cover characters A and B. And when I look at the second line, that would let me cover characters A and C. However, I don't need to double add A into my list. Right, so notice that for group 3, although we have A repeating twice for 2 separate lines, in our sort of logical output right now, we should only list A once. So again, what we're trying to do is list out the unique characters that any line in the group provides. If I look at group 4, notice that all of these lines just have an A, so that means in total group 4 only has A as a character. And likewise, group 5 only has a lone B. So again, next to every group, which is a box right now in my diagram, I have listed the different characters that this group contains. In the long run, this problem doesn't ask us to return the characters that the groups cover. Instead, they want us to sum up all of the different characters that any group covers. In other words, group 1 gives me 3 characters, group 2 also has 3 characters, group 3 has 3 characters, and groups 4 and 5 both have 1 character. All I need to do now is add up each of these numbers and take their sum. So doing the quick calculation here should give me a final answer of just 11. And that's the number I should return for part 1. And so conceptually, there's nothing much to this problem, although we're probably wondering what's a cool pattern we can use to basically count the number of unique characters that a group has. And so to do that, we could use some interesting mechanics like some set theory. In other words, if you had a set of characters, call them A, and also a set of other characters, call them B, if you wanted to figure out all of the unique characters that they cover together, you're really just looking for the union of both of these sets. So again, kind of the way you kind of interpret that in terms of set theory and some Venn diagrams is basically you want to look at everything that's inside of these circles. So the elements that are only in A, as well as the elements that are only in B, and also the elements that are in both A and B, that is their overlap. If you're familiar with some mathematics, we call that the set union. With that, I think we're ready to code this one up. So here we have my input file. If you're following along, you definitely want to download your own input file from the Advent of Code site. So why don't we start by separating all of these lines from different groups. In other words, looks like from one group to the next, we just have a blank line. So over in my boilerplate, what I'll do is just go ahead and start by splitting my string data by the double new line character, because we have one new line character to go from the last entry in our group to the empty line, and then we have the empty line to the next group. So it's 2 new line characters in a row. So I'll just start by calling that function. So I'm going to await, and I'm going to do my read entries. That should return to me an array of every group. So I'll save that. We'll call it groups. Spell that right. For now, I'll just console.log maybe what the first group looks like. So what does groups at index 0 look like? So we'll give this a go. I'll run my part 1. Yeah, and there we have our members of the first group, right? Just like it is in our file. And so just for this single group, why don't I figure out a way to get basically all of the unique characters on all the lines in this group. So I think here's where we should create a separate function to kind of separate that concern. So I'm going to call, we're all going to create a helper function. I'll just call it union, because I think this is a great opportunity to actually leverage some like set theory operations, which kind of the grand scheme of data structures and algorithms could be useful quite often. So here's what we'll do. I know it's really straightforward just to take any one of these strings and to convert it into a set of its characters. In other words, if I just quickly open the node REPL, I just take, let's say, this first string. I think if I literally said, hey, like new set, and I pass in some iterable data, so a string I think is already iterable, so just pass in the string, that should just give me a set containing those characters as elements. And the really cool part about using a set here is just like in math and most general sets, every item of the set is going to be already made unique. In other words, if I passed in, let's say, x, y, 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 z, z, then the members of my set are just x, y, z. So that's really awesome. That way, when I implement my full solution later, I don't double count the same character twice, right? Which is really important. Even if different lines of the group have the same character, I only count that character once, right? And so why don't I just create a union method, which hopefully takes in, we'll say like 2 sets right now. In other words, if I had a set1, we'll say const s1 equals, so just, playing around with some ideas, s1 equals a new set of the characters, we'll say x, y, z. Then I'll create s2 that contains the characters, we'll say y, y, z, w. Then their union should just be all of the characters that are in both of these sets. Maybe to be clear, I can also just exclude the second y, right? Because it's going to be made unique anyway. In other words, the result of doing a union on S1 and S2 should be, we'll say, the set of just x and y and z and also w. So a few things, when I calculate the union, I should not, of course, double count any of the characters, but I want to include any characters or any members that are in either set. So this is really easy to do. And I kind of wish that this method was built into JavaScript, but it's unfortunately not. It is built into languages like Python though. So I'll say I'll take in set1 and set2, and I'll return a new set. So I'll create one here. I'll say there new set equals an empty set. And now all I need to do is to iterate through both of my sets. So I'll start by iterating through every element of set1. So I'll say let item of set1. So that gives me every element of set1, and all I need to do is just add it to my new set. So new set.add that item. And I can just do the same thing for set2. And what's great about this code is if an item is common between set1 and set2, it's not like it's going to exist twice in my new set, because sets just automatically show an element only once. So from here, it should be as simple as just returning the new set. So this is a nice general purpose, like set union function that could be valuable in more than just this advents of code problem. Let's give it a go and just run my kind of arbitrary mini test over here. So let's see what the union of these two sets is. We'll give this a shot. So S1 has already been declared. So I'm getting a little error here, so I want to comment out or delete this bit of code. Try that again. Nice, and there's our expected output, right? I have the set that contains the union of both. So how is this going to be useful? I think I'm ready to actually work this into my main function, right? So over in the solve function, let me start by iterating through every group, we'll say. So I'll say for let group of groups. Nice. And what I need to do is be sure to look at the separate lines of a group. So this is a group, right? This is like group 0, this is group 1, this is group 2. I want to get, just for like, let's say group 0, the separate lines. So for the group, I'm going to split on the new line character. So I'll say group.split on the new line character. So it should look something like this. So I'll give me the different lines of that group, right? And what do I want to do with these lines? Well, I just want to find their union, right? So there are a few ways you can do this. You could use some like fancy built-in methods like reduce. I think I'm going to keep things kind of straightforward and just do this manually. And so I'll create, let's say, the union set. I'll just say union set. And I'll begin this union set with just the empty set. And now what I can do is just iterate over every line. So I'll say for let line of line. So that's basically just a string. So a line would be a single string like this or this. And so for every single line, I'm going to turn it into its own set. So I'll say create a set passing in that string. That should give me a set of it, right? So I'll say const, I'll say, I don't know, line set. That's a set of the characters in the line. Now all I need to do is union this line set with my union set. So if I did this, if I called the union function on my union set, as well as my line set, I'm going to get basically both sets combined into one. And all I should do is just reassign that into union set. So the way I'm using this union set variable is, it's kind of acting like a set that accumulates all of the different members or different characters from every single line, right? And so now that I'm doing this operation, we can go ahead and I think just look at the elements in that union set. In particular, we really want to look at the size of that set. So if you're unfamiliar with how to find the size of a set, it's just set.size. So kind of dissimilar from something like array.length, right? It's set.size. And in the grand scheme of the problem, what they want us to do is, after we find the number of unique characters within a group, we want to do is take the sum of all those characters across every group. So I can say my let total equals 0. And after I calculate the size of every group, I just do total plus equals that quantity, right? And if this is working, by the end of our for loop, once we add every group's size into our total, we'll just return the total. I think we're ready to test this code now. If this code is working, we should get the result of 6,416. Let's try it. So node part 1. Nice, and there we have our solution. Cool, so this is some nice general purpose union function. You can probably find a way to write this code without writing this kind of generic union function. Although I kind of did this on purpose because I know that this sort of structure is going to be really extendable for part 2. That being said, let's head back into the drawing board and discuss what we need to do for part 2. All right, let's talk about part 2 now. So here's kind of the diagram we built for part 1, and we're just going to have to adjust it a little bit for part 2. Recall that in part 1, we were basically answering our question for each group. That is, what are the letters that appear on any line of a group? Whereas now in part 2, we want to kind of finesse that question a little bit, and this time figure out the letters that appear on every line of a group. So notice the difference in language now. So in other words, for a particular group, I want to find the letters that are common among all of the lines in that group. In other words, if I look at my first group, will our answer actually change? And the answer is no. It'll actually return the same result of ABC. Because I only have one line in this group, I could say that A, B, and C appear on every line of the group because there's only one line to satisfy, right? However, things get more interesting in the second group. If I look at group 2, so I'm looking at the different lines inside of the white box, I have to ask myself, what are the letters that appear on every line of this group? And there is actually no overlap here, so the result is going to be no characters. So here I'll just put like an empty array, I'll say. That's because there are no letters that appear on every line of group 2. If I look at group 3, the only character that appears on every line is just the A. For group 4, it's also just an A, and group 5, it's just a B. And like before, what I want to do is take the sum of these number of characters, right? So it's basically just 3 plus 0 plus 1 plus 1 plus 1. So the answer we should return here is just going to be 6. That being said, how can we go about implementing this? Well, we can still use some set theory. So like before, we have some set of characters A, and we also have another set of characters B. This time around, we want to find the characters that are common to both of these sets. In other words, we're asking to find their intersection. So if you can imagine that the characters are represented, by these circles, we're looking for the characters that overlap. That is, the characters in this sort of overlapping region. And we call that the set intersection. Using some JavaScript, you can just write our own methods to perform intersection on these sets. With that, I think let's go ahead and hop to it. All right, so part 2 should just be a small variation on part 1. So here I just copied all of the code from our original part 1. We definitely want to change things around. So recall that when we find the union of two sets, we're getting the elements that are in either set. Whereas now when we take the intersection, we definitely want the elements that are common to both sets. So for a member of the intersection, it must be in both sets. So I think I'll keep this code here just so we can compare it easily. But if I wanted to calculate the intersection of two sets, we'll call them set 1 and set 2. It's actually really straightforward, especially since, sets, built-in sets, have a constant time lookup. So I'll still create my new set, and I'll still return that new set by the end. This time around, all I need to do is really just iterate through one of my sets. So I'll say for let item of set 1. So just some logical implications here, right? As I iterate through set 1, I definitely have an item that is absolutely in set 1. Kind of seems like a dumb statement to make, right? But if this item is already in set 1, then the only thing you need to do in addition to that is to also verify that it's in set 2. In other words, hey, if set 2 has this item as well, so has is how I can check if the item exists in a set. So if this returns true, that is, if the item is in set 2 as well, then that item must be in both set 1 and set 2. So I can just add that item into my new set. So new set.add that item. So why don't we go ahead and test this function in isolation? And this is a nice general purpose intersection function that you might even find useful for more than just this Advent of Code problem. So if I had two inputs, we'll say, I don't know, const s1 equals a new set of the characters aple. Then I created s2 and it had some common characters. We'll call it pol, right? So the only characters in the intersection here, I believe, are just p and l. So in other words, if I found the intersection of s1 and s2, I should just get, a set containing p and l. So something that looks like this, right? P and also an L. So let's just verify this behavior for our helper function before we incorporate it into our main function. So I'll run part 2. So there I have my PL. You can ignore this result. That's just kind of left over from our original solve function. But at least we verified that our intersection function is in good shape. And now it's just a matter of changing our solve function in a very superficial way. So we don't want to use union anymore. I'll kind of just comment this out, or maybe even delete it. And now we just need to change our code a little bit by possibly renaming our variables. So maybe instead of union set, maybe a more apt name would be our intersection set. And of course, I don't want to call the union function. I actually want to invoke the intersection function. However, there's also one really important thing we need to do in our code. I can probably imagine if we ran our code as is, right? The answer we should get is 3050. I don't believe this code will work because of a very small but important detail. Yeah, here we get 0, and you'd always get 0. And the reason is, on line 13, we start our kind of accumulator or our intersection set with no items. And if you do that, if you have a set with no items, and for that empty set, you try to find the intersection of that empty set with anything else, well, the intersection is going to be empty, right? If one of your sets that you pass in to the intersection is empty, then it's not possible that there are any elements or any items that are common to both set 1 and set 2. So it's a very small detail. Instead of initializing our intersection set with nothing, with the empty set, instead, why don't we kind of just arbitrarily set it equal to the first line in this lines array. So I'll say new set of lines at index 0. I know that this is going to be pretty safe to do, I think, because a group will have at least one line in it. And from the start, let's say that we initialized the intersection set with just the first line. So it would be this line, right? Well, in the context of our code, when we start our for loop, the first line set that we look at will actually be for the same line. So it will still be for this set. And so we'd basically be intersecting this set with itself, which doesn't really change anything. But the upshot is on the next iteration, our intersection set would be this, but then our line set would be this. And now I'm starting to, compare intersections across my lines. So I think with that, let's go ahead and give this a run. Again, if this is working, we should get 3,500. Nice, and there we have our part 2. Again, what I really want you to take away is how we just, made a slight adjustment to our code. We wanted the intersection this time. All right, programmers, that's all I got for this video. Hope you enjoyed it. I'm a huge fan of math, so I had a lot of fun making this video. Haven't really got to do some set theory stuff in quite some time. But with that, I'll see you tomorrow for day 7.